Hello, Manish.
Yes, hello. Can you hear me?
Yes, very clearly. Hopefully
And I
you
just
can hear
wanted
me
to
too.
check for screen sharing also.
Sure. Let me just stop presenting. Now you should be able to share your screen.
Yeah, I am not very much or frequent user with this Microsoft.
Yeah,
So
so there's this upwards arrow with a square around it in
yeah,
the
so I'm
toolbar.
seeing the screen. It is showing the. I think it is for the entire desktop, probably.
Yeah, I think you can choose also a window if
I see.
necessary, but
Okay,
if not,
but it's giving the only desktop window.
okay, then maybe
Let
because you're
me.
doing it through the browser, right?
Yeah. Oh, yeah. Right. Right.
Uh,
Or because there is some bug in the software also.
yeah,
In
I
my
know it's
desktop.
a
I mean, it is not. Or you mean I should switch over to the, or maybe it may not be worthwhile to do the experiment.
right, yeah, because we are about to start in 4 minutes. So
Yeah, right, right. I think we could have. Okay, anyway. So still it is not. Also, one more thing. I have the. Okay, that is also one thing aspect. Okay, yeah. Okay, okay, fine. It is showing this. I think you can see the screen.
yes, we can. It's not in full screen, but we can see it very clearly.
Let me do one experiment.
Sure.
I'm just reconfirming you are seeing the same screen because I switch over the screen from one
Yes,
screen to
it hasn't
another one.
changed. Do
Okay,
you want to
good.
test moving the slides maybe? Just to make sure
Okay,
everything
yeah,
is
right.
working.
I will go in
And
the
maybe full
projection
screen,
mode and
yeah,
move the slide.
exactly.
Okay. I,
So the slides are changing, but it's not in full screen mode.
yeah, just a minute. Slides are changing?
Yes, but not in full screen mode.
Yeah, okay, okay. Let me just. Yeah, now I think the full screen.
It's not yet.
What is showing the two screen? That means?
No, it's just showing me your first slide, but not in full screen
No,
mode.
no, but in full screen, right? Or
No,
no?
Anup
no,
sir,
as a normal.
हॅलो Anup sir,
Hello. हाँ, Padmakar.
एंटायर स्क्रीन करायला सांगा त्यांना
Acha.
शेअर.
Manish, so the Padmakar who is helping with all of
Yeah,
this, he's suggesting share the entire screen. That's the only way it
yeah.
can go into full screen.
Oh, okay, I will stop one screen. Probably it is creating problem to screen one and screen two.
Ah, okay, yeah, that might be the issue here.
How is now?
I can see the screen again, and if you can
Okay,
try
and
going
now
into
it is
full,
in full screen
perfect. That's
and it
perfect.
is changing
Yes. No, not as yet. Okay, yes,
now.
it's changing. Yes,
It is
perfect. Yeah,
changing.
yes, I can see that clearly.
Okay, good.
Wonderful. Okay, so maybe for now we can just stop sharing and or if you want to keep it on, you can keep it on. Huh? I'll just do a quick
Yeah,
introduction
that
and
is
then
on
we can
safe side.
makes sense, makes sense.
Or maybe
Okay, we'll start off in 1 minute either which way. It's
yeah.
almost
Okay,
3 o'clock,
okay.
so that's perfect. Great. Since it's 3 o'clock, we will start off. So, hello everyone. Welcome to the third volume of the National Atmospheric Chemistry Seminar Series. Today we are in luck because we have Manish Naja who's going to be talking to us about trace gases over South Asia. And it's basically an overview of what all has been happening in terms of observations and their science, and also looking towards the future of it. Manish, just to give a very quick background, has had a very fruitful career, but he basically started off doing his doctorate. So his research career started off at PRL, as some of the top scientists in India had started off. And after PRL, he went off to Japan. He was in Yokohama at Jamstec for a while doing his postdoc. And after which he joined ARIES, where he's based at right now. And he is actually he's a senior scientist, obviously, over there, but he's also the chair of the Atmospheric Sciences Division at ARIES. Uh, while being at ARIES, he's obviously done a lot of work on observations of trace gases, which include things like ozone and other greenhouse gases, measurements of aerosols, not just at the surface, but also balloon-borne instruments, which has given him a very good idea of what's happening through the entire layer. And some of the top data in India on trace gases has actually emerged from his group. He also led a group at ARIES to successfully set up the 206.5 megahertz wind profiler, which is one of the few in the country, and provides valuable data, which is helping with things like weather forecasting, etc. He's also been involved in different national and international projects, lots of field campaigns. His expertise is really making observations. He's supervised more than 10 PhD students and has published more than 100 papers so far in top peer-reviewed journals. Presently, he is busy working on the ISRO ATCTM projects, and he's also leading ST radar facility at ARIES. He is interestingly the co-chair of the IGAC Mango group and has been on the SSC of the IGAC and ICAC-GP groups. With that very short introduction, I'm going to hand over the mic to Manish, and then we'll do some questions later. Manish, the floor is all yours.
Yeah, thank you, Anup, and also the group of people who has initiated this very nice activity, National Atmospheric Chemistry Seminar. And I hope I'm audible, right?
Yes, loud and clear. You can go ahead.
Yeah, so as you can see the title, I was basically I was attempting to cover the trace gases study over the South Asia to give us a feeling about the other region, but somehow I could not combine, and major activities focus in India and some portion in Nepal. But I was thinking to cover broadly other region, but let us see. So as we know, just for the sake of completeness, I'm trying to show this slide. And when we talk on the trace gases or the chemistry, you can see the troposphere and stratosphere is the major focus region. And in this region, you can group in the two subgroup. One is the basically activity which are dealing with the trace gases, with the short-lived things, and directly dealing with the air pollutants. And other group of species or the trace gases are on the long-lived. Those are basically greenhouse gases. So that composition is, of course, well known to the community. But here, what is the main aspect I am trying to say when we talk in this, the troposphere and stratosphere and the process-wise, when you say in the chemistry, like which is dealing in these trace gases, that is looks like the more complex. And in this complex, when I say, because of course the physical and dynamical process also are rather complex, but in the chemistry, like you considering the lifetime of the gases, the things becomes more complex. And when you talk again in the tropospheric chemistry, here the ozone play a major central role. And why I say ozone again? Like because ozone is a major precursor, or also one can say that it is the only precursor for the hydroxyl radical. And hydroxyl radical, as we know, this plays as a detergent in the atmosphere. So it is most of the gases are and the lost by this OH radical. So for this subject, the trace gases observation, one can use the surface-based observation, balloon-borne, aircraft, and shipborne modeling, and satellite-based observation. So again, come back to on the central point on the ozone. As of course, again, this slide I am showing for the sake of completeness. Like this, we know the ozone is very harmful for the human health, and also the have very bad impact on the vegetation. And the two aspects would like I would like to draw your attention. This is, you can see, the theoretical model calculation, and you can see when ozone level is increased to almost 100 or 100 ppb or 120, the some of the crop, not all the crop, but some of the crop like soybean, you can see in this yellow color. I don't know this, my mouse is also visible when I'm scrolling here. So you can see the soybean, peanut, or cotton, they can have the reduction of yield by almost 50% or less than that. So for some of the crop, it is very worrisome. And also you can see on human health, there is a lot of paper has come with Indian group also, like almost 29% of the global death are due to poor air quality in the South Asia. And to again see on the process wise, like when you see the in the troposphere, why, what is the importance of this study in this region, and particularly when you talk in the South Asian northern part of South Asia or Himalayan region, the effect, you can see whatever the emissions are there, they are basically going up to the Himalayan region. And this on the figure, you can see one air mass trajectory is calculated, and it shows like the pollutants or the levels in these regions can be influenced by the even long range transport, even originally the air mass which is coming from the Europe or Africa. This green color you can see in winter time, when the influence from the Africa, Europe can also come. So major impact, like whatever the emissions or the process are happening over the one region, like for example over the Indian region or South Asia. Apart from that, there is significant contribution from the European region or Africa. And here this one analysis is made, and you can see this the percentage contribution wise from the air mass, and you can see enhancement in the ozone. You can see African and European air mass here can have the enhancement by in the 10 to 15%, and the level of around 40 to 45 ppb of ozone. So that is the basically in general, like the process or the emissions, not only can control by the one region, this is or the source region, but from the other different part of the continent. So here, of course, I'm trying to show the institute from where I come. This is the Nainital ARIES Observatory, and you can see this is located at the mountain peak. Altitude of this is around the 2,000 meter. And one very the different aspect of this location, the institute is located at the mountain of around 2,000 meter. But in the background, you can see this is the plain region. This is called Halwani. This is altitude of around the 200 to 300 meter. So you can see in the within very short region, you have the altitude varying from the almost the 200 to 300 meter to almost 2,000 meter. So this is the basically you can see different lab in our place. And here I'm trying to show the some of the facility we have at the ARIES, and for the atmospheric study. And we have the facility for the surface observation, balloon-borne observation, and the LiDAR and radar, which is recently installed. When we talk on the surface base and also on the trace gases, we have the ozone central gases like ozone, CO, NOx, and SO2. Of course, we use a tracer. Apart from that, we have the greenhouse gases observation. Hello. I think
Sorry,
some noise.
Manish. There was somebody speaking. You can
Okay,
go ahead now.
okay. So to come back to on the topic, I just been trying to show on the region, and of course, when we say the tropospheric chemistry, I mentioned ozone plays a central role. So I just wanted to do some flashback on the historical thing, like when the observation started. Of course, many of us might be knowing, but for the young generation, for the information, I'm just trying to mention this slide. So historically, surface ozone observation network started in India by the IMD, and earliest data arrived from 1971. Those were the surface-based observation and also the ozone sonde observation. Later on, around 20 years later, the ISRO started one network-based observation, that is again by the surface and the ozone sonde sites. And then a few years later, several organizations like MoES, DST, MoEF, and ISAR, IIT, CSIR, they have started this observation from the different network. And this here I'm listing the things which are on the not network based also. And one very interesting activity started by the group in IITM on the basically SAFAR, which is now again now presently taken over by the MoES and IMD. They started the observation of the not only ozone but different precursor gases within a city, like for example in Delhi, Pune, and now spread it over the Bombay and the other several cities, for the almost network of the observation from the more than 20 to 30 sites within a city. Now here slightly more detail on the IMD network. Like you in the map, you can see the IMD network have the ozone observation in ECC, and now of course ECC observation was historical, but now they few years later they have started the initiated the observation using the UV observation, because for the surface ozone UV absorption based instrument is considered to be the most ideal instrument. And they also have the ozone sonde observation. And the ISRO network, the very uniqueness on ISRO network was in the ISRO observations, ISRO network observation, not only ozone, but the different precursor gases like CO, NOx, and hydrocarbon were started from almost the 16 site. And one another important point on the ISRO network, you can see in the map, in Indian map, they were representing from different regions, like from high altitude site and the island site, coastal site, and semi-rural site or urban sites. So to have the representation from the different sites, and here you can see the some approximate value, average value from these sites are also shown with the different color code. And it is very interesting, like you can see, like in northern part of India, the or in the mountain side, the high levels of ozone are also seen, but that will be also in more detail I will tell you. And the initial network, the ozone sonde observation were also started, and it is the observation based on the electrochemical method. Not it is basically standard sensor which is used for the observation of ozone, and this is different than the IMD sensor. Here I'm trying to show some of the not like one important results or two important results from network of observation from ISRO. On the left hand side, this is the historical observation, which shows the increase in ozone at the Ahmedabad site. An important point is like increase in ozone seen in the winter time, when we expect the photochemistry is not very active, but the enhancement was very much large. Almost you can see 30 to 40 ppb of increase in ozone. And the on the like from India side, this is the for the first time on observation data is used to calculate the loss on the crop growth. That is the from the observation of the 16 sites spread over from north to south and east to west region. You can see the observation data is used again for this calculation. You can see this EOT40 or M7 method are used, and of course there is a large debate on these two methods, but more or less you can see on this observation based study have shown the loss of the crop by almost the 2 million ton to almost 8 to 9 million ton in case of wheat. And in case of rice, this loss is slightly less. And why I'm trying to emphasize on this, this is very much different than the total modeling based the observation and the results. So this I feel that maybe more reliable, but of course the levels of the loss is also much higher. Now, the other aspect of the observation network, you can see this to try to understand what is the present status of our understanding. And this is the model-based study made by utilizing the observations from the different site, from the different group it is obtained. And you can see compared with the two model, one is the global model, WARFChem, and another is the Mozart. And you can see there is some sites show a lot of difference. like here from January to December, like for example, you can see in Ahmedabad or Pune, there is very significant difference in the seasonal variation, and also the levels are also very much different. The observation is in the red color. You can see if compared with the WARPM, for example, in the Pune, the difference is almost, you can see the 40 ppb. So this indirectly it is indicating there is a lot of missing component or missing in our understanding on this process wise. Now here one can argue there is difference in the emission, so that is the another point to see. But another important aspect, you can see another site in the South India is Anantapur. Their agreement is very much in the both the model BORFCAM and the Mozart, they are showing very good agreement. So then one can again argue where the emissions may not be issue. So again, it is combination of the regional process and the role of the emission in the particular region. Here I am now, apart from the ground-based observation, I am trying to take is slightly on the oceanic region, and this is the the trigger point, which is made the observation made in the long back in the 93, 94 by the ship-based observation throughout the globe. And of course, this experiment was the lead by the Paul Crutzen, famous scientist from the Max Planck. And you can see this is the vertical line, and showing the ozone levels from the northern part of the North America to, you can see the other part of Russia. And in the two seasons, the top panel is from, you can say, from July to October, and the bottom panel is in the winter time from November to February. Now here the main important point which has come out, like over the Indian Ocean, the ozone levels were shown to be very high when you compare with the other part of the globe. And this is the basically, you can see the trigger point for the starting one famous experiment in the, we call the INDOX, Indian Ocean experiment, that was conducted following this outcome. And this also you can see realize like Indian Ocean or this part is the only region in the world where it is connected like from the northern boundaries connected from the landmass. So you can see the outflow from the northern hemisphere is directly pumped into southern hemisphere in the Palestine region. So this outcome or this study has led to one big experiment called the Indian Ocean experiment, and I am trying to show some of the results. And also, apart from following the INDOX or the very nice result from the INDOX, the the scientists independently carried out another experiment called the BOBAX and the ICAR, and then followed the later on several experiments. So here you can see in this experiment, the ship crews of these two INDOX and BOBAX are shown on the right hand side. And the left hand side, you can see some compilation of ozone variation from this all the campaign from 15 degrees north to almost 20 degrees south. And here you can see the black line is the colorful different color symbols are showing the observation, and the purple triangle, the square triangle, tilted triangle is in the model. And you can see, like, of course, it is known in coastal region, the ozone levels is varying from almost 30 ppb or 25 ppb to almost 75 ppb. When you go deep in the Indian Ocean, the levels are basically fluctuations are very less, and levels are also down, as we know. But the important point is here you can see agreement with the model. In the southern the ocean, the levels are in somewhat in agreement, but when you come to the coastal region, the difference in the model and the observation is almost, you can see, the 50 to 60 ppb. So then again indicating that one has to have the very deep the understanding of the process or emission sources from this part. Another part is also, apart from the Indian Ocean, there is also comparison between the Indian Ocean, Arabian Sea, and Bay of Bengal. It is also given here on the right hand side. Like if you compare among the three regions, the ozone levels are relatively higher in Bay of Bengal when you compare the Arabian Sea. And this feature is also seen in other species. I'm not showing here, like in carbon monoxide or methane or even in SF6. So that is trying to show like Bay of Bengal is having the weather, or it has to again the confirm whether the outflow from the South Asia or continental part is having the significant or greater impact on the Bay of Bengal when you compare to Arabian Sea. So you can see that is the one major point has come out from this work. Now, another the very nice study is made over this Indian Ocean experiment, also followed by the different observation on the process wise. Here, of course, we know the Darwin pattern in ozone is very much different over the oceanic region, and here you can see the blue color line showing the Darwin variation. And when you try to make this the Darwin pattern using this model, the most of the model fails, simple model fails to produce the Darwin pattern. So one has to have the different the chemistry and also dynamics. And you can see this in this Indian Ocean experiment, when you consider the entrainment velocity differently, like in evening time, night time, in particular night time entrainment velocity is slightly more, then you can see some resemblance with the Darwin pattern. But still you can see the amplitude is not matching. Then later on, different group of scientists, including I will say the Mahajan, who is basically very much dealing with the ozone chemistry in the marine or halogen chemistry, it was proposed that for to match this amplitude, the role of the halogen chemistry, particularly Br or iodine, that is playing a very much important role. So this from this experiment, it was also realized that in this part of in the Indian Ocean, that kind of the process is also playing a very important role. Now here I'm trying to come on the again on this Himalayan region and in the IGP part, and this is the one study we made, and also trying to see the how the global models is performing over this part of India. And you can see like in this time, like the more or less in the there is significant difference in the seasonality between the northern part of India and the central part of India and the southern part of India. Like you can see, compare this the springtime peak value in the northern part, and you see blue color in the Trivandrum, that is very much indifferent. And the difference is again in seasonality, you can see almost the 40 to 50 ppb. And this is on average I'm telling, like case by case, the difference is much larger. And again, you can see another aspect, like there is significant difference in the level between the nearby site, like this Pantanagar and Nainital. These sites are basically, you can say, hardly 30 kilometers away, but there is very significant difference in their level. And you can see again the global this model, they compare, they show some variability, the match and seasonal variability match, but the levels are very much different, as shown earlier by the warp chem study also. So there is basically a strong need to understand the different process in this part. And this is the you know, comparing with the satellite observation. So this was the more or less some agreement with this total column of the ozone. Of course, this I will skip it. This is a very general thing, and I'm trying to show the how the chemistry play a role, like in NOx in different environment. That now, yeah, here this is one important aspect. I'm trying to again focus from the observation at the Nainital in the mountain side. You can see the ozone as expected. We are in the clean side, so daytime levels high are almost absent, and you can see the dip in the ozone in the mountain side. So this is again playing the showing the role of the dynamics in this hill station side, and role of the chemistry is slightly in the not very significant. You can see in situ chemistry, and similarly you can see the CO and the NOI in this part. The levels are much lower, and they are showing very much different pattern. Like daytime of high level of ozone in CO is prominent in this region, and similarly you can see the NOI. This shows some tendency of high level of the NOI in daytime. Of course, in the springtime, you can see some tendency of the semi-urban kind of thing, but otherwise it is showing the very clean side. Here are some of the other features from this Nainital side. I'm trying to, I think maybe cover this in the slightly later. I will skip this one. Now, another important aspect, like you see, is the biomass burning. And now you can see in the entire Asian region, there's one analysis is made to understand how this the forest fire is behaving, or the seasonality is so in different part of Asia, like South Asia, Southeast Asia, and East Asia. Because our the main aim was to see the emissions from this forest fire. So if you see on the right hand side, like on more or less in general, in Asia, the springtime, the high biomass burning is seen. Of course, when you go slightly in detail, you can see South Asia, this fire is dominant basically in the March and April, sometime in the May. And this analysis is made using for the modest fire count. And one can argue they are using the different satellite product like beads or the TSR of this old edit. There is some difference in the seasonality, but that is the basically the more the topic for the detailed analysis. But important point, if you focus in the South Asia and focus on the confidence limits of 80%, the dominance fire in the South Asia is peaking in the spring month. But there is some fire count in the autumn or in October, November, but that is not contributing very significantly. Now, another important aspect, like if you talk on the emissions, we compare the emission data from the two emission inventories, like GFAS and GFAD. And important aspect of this finding is like there is difference in the seasonality in the two emission. So that means there is some issue in this emission inventory. Like you point here on the left hand side, like GFAD is showing the higher value in the springtime, whereas and again in the northern part of India, or whereas you can see in the northeast India, the GFAS shows the higher value. So there is differences in the emission inventory. So one has to take care of this aspect, or maybe like one has to use these emission inventories very carefully. We also try to see the assessment of this emission, what is the impact on the black carbon and the ozone in this part. And as expected, you can see the high level of the ozone and the black carbon when you have the events of the fire count or the more fire activity in this part of the India. Now again, like here you can see in the bottom side, important aspect, like it not only the fire and the forest fire, it depends on the air mass. Like one can see the fire in a region, but depending on the transport of the polluted air, you can see enhancement. So that is the one important aspect that one can see here. This is another aspect of the biomass burning on the impact on the aerosol, on the not on the black carbon, but elemental carbon and organic carbon. And you can see like as expected, the elemental carbon do not so much in significant enhancement, but organic carbon is showing very significant enhancement in this period. And that is also the correlated with the residence time of the air mass. So that is the one aspect. Now I'm coming to another the topic, like we have the extensive observation of the ozone from the balloon flight. And what is the important aspect I'm trying to show? Like this biomass burning is not only affecting the surface layer, but it is leading to enhancement in the ozone layer at the not ozone, like in the lower part of the troposphere, up to around 5 to 6 kilometer. You can see in different year the enhancement of ozone is seen like by almost you can see 10 to 15 ppb, and that is basically you can see very important, because this is indicating at the lower part the biomass burning, the emissions of the CO or NOx, they are going up and also leading to the enhancement in the ozone by the intensive photochemistry. So because since the observations are in the springtime, so there we have the sufficient the solar radiation or the for intensifying the photochemistry. Another aspect, this is the very much important, and we initiated in the from our side, and this is the one comparison I'm trying to show with the two sites, like in the Nainital and the Kathgodam. Nainital is the mountain side, and the Kathgodam we are the fertile side, which is the source region. So this shows that there is a significant difference in the hydrocarbon level as expected. And you can see like in Nainital, which is the mount representing the Himalayan region, central Himalayan region, dominates by the ethane, whereas in the Kathgodam, it is dominated by the propane. So as expected, like depending on the emissions or the source region, this variation you can see. Like again, like the correlation between ethane and propane, it is very much correlated in the mountain side, and that is one can say because indicator. Of course, it is with this observation, it is not possible to confirm. You have to have the more the tracer observation, like the Dr. Binayak, he is doing at the ISR Mohali. So we don't have that kind of the PTRMS, but we have the simple instrument gas chromatograph. So, but it is giving indication, like in automobile and the biomass burning, the source are dominating in this hill station. They are ethane and propane are showing the very good correlation. But if you see in the fertile region in the Kathgodam, they are not very much correlated. So that is because the in the Katgodam, the dominant source is the basically another the butane coming from the gas gas refilling station in this part. Apart from that, like when we're talking on the biomass burning, the influence is also seen on the surrounding region in the Kathmandu. This is basically experiment done during the one Suscat campaign, and it is shown like the biomass burning which is taking place in the northern part of India that can influence the levels over the even in Kathmandu Valley depending on the air mass. So you can the enhancement in the carbon monoxide and ozone both were seen during this period when the air mass is the transporting the air from the northern part of India or Punjab or Haryana region. This is another experiment we conducted in the Pantnagar side. We doing the max dose instrument using for the observation of the formaldehyde and we call the chocho, and that also shows the very high level of these species in the springtime. So again confirming the enhancement of the ozone in spring, not basically in the summertime, which is the intense period. This is the I will skip this slide. Yeah, this is the another aspect, of course, not related to the ozone, and we are doing this observation of the greenhouse gases. Of course, the in IITM, the US Tiwari is doing excellent work in this. But we are in the Himalayan region, we are having this observation since 2006, and the continuous observations are being made for the different greenhouse gases like CO2, SF6, N2O, methane, and this is showing very nice significant trend of the increase in CO2 from almost 0.7 to 4 ppm per year. An important aspect of this, like seasonal amplitude. The seasonal amplitude on the CO2 in Nainital is much larger when you compare with other sites, even like site in the Mauna Loa. And that looks like that is some role of the biosphere in this particular region is playing this role. Another aspect is the basically for the utilizing the our observation and the using the WARF model capability to see or understand the how ozone the control studies can be made, and this is the generally considered when the ratio of the formaldehyde or NOI, they decide whether NOx levels are controlled by the NOx limited regime or they are basically fall in the VOC limited regime. So this analysis is made for the South Asia, and you can see figure for the 4 different months, seasons like in winter, spring, and summer and autumn. Of course, this analysis was made for a specific month representing the season, and one can see like in general this if you talk in general throughout the year, this India is basically an NOx limited regime, but you can see in the winter time or some part of the spring in the IGP region is some tendency of VOC limited. So that means in this period, the NOx, they may not have the very much significant role. Of course, the threshold levels are essential, but you can see in general when the rest of the India, including the central Himalaya, Nepal region, these are largely controlled by the NOx limited regime. So you can see very strong seasonal change in this. Yeah, so I'm coming towards the end and I'm trying to show like the few years back, almost 10 years back, the very extensive observation or campaign-based study was made at the Nainital from in collaboration with the US Department of Energy and ISRO and IISc for observations of the aerosol and radiation. But I'm trying to emphasize here, this observations of the trace gases or chemistry was not in that much dominant phase. So this is basically on aerosol studies. Another campaign was conducted in Nainital in collaboration with the Switzerland group in the Zurich and IITM Pune for conducting the balloon flight. And then main aspect was to see the effect of the Asian summer monsoon in E2LS region. And for the first time, the observations of the water vapor and the aerosols were made using the balloon flight. So this experiment was conducted in 2016, and almost 25 flights were conducted. And later on, after 1 year, the coordinator of observation was also conducted in the Kathmandu. Now, why I'm trying to say like this, the UTLS region, particularly for ozone and water vapor, that is very important in the sense that we know from the radiation purpose and also from the exchange of the different gases. And by seeing this important, now we are planning to repeat this campaign this year in the monsoon. So there are planned to conduct this in monsoon and also, if possible, in the post-monsoon period. This is which I was mentioning the one Suscat campaign we conducted in the jointly in the Kathmandu Valley and also some of the sites in India. From India, basically, the Aisar Mohali and Nainital was the prime site, and the 5 sites in the Nepal was also conducted. For this experiment, several institutes from the Nepal, Germany, and Korea, China, and India participated, and the main importance or the main goal was to assess the pollution or outflow from India and Kathmandu, how they are going to influence from the region. So you can see, like after the INDOX was conducted in the late 90s, and this is in the 2014-15. You can see after almost 15 years, the one the campaign for the trace gases or the chemistry was conducted in this part. Now again, you can see such a large campaign is not or no campaign was conducted in this region in the last, you can say, almost the 10 years. So this is a time basically one has to realize on the importance of this aspect. Here is I'm trying to show one the training course was conducted in the Nainital in collaboration with the IGAC, and where the 30 scientists from the 17 countries participated. So here I'm trying to conclude now whatever I spoke and what the in the future outlook and the future need. What is the basically has to see, like, always there is when you talk on the Indian Ocean or University of Bay of Bengal, there are also always focus in South Asia. One has to see whether what is the influence or the outflow from the Southeast Asia. So some that aspect is almost missing in major global studies, like the how much contribution is there from Southeast Asia, and that you can see here model simulation like the CO tracer. So the pollution level which I split from the South Asia or even Southeast Asia, they go up and then redistribute in the entire region. Now the specific what I feel, this is also a good platform to some of the things which is the basically I feel or my most desire, like the observation or the extensive observation. Some of the key reactive species are very essential, like for example, like NO2, formaldehyde, HNO3, or radicals. Now, why here one can say there are a lot of observation of NO2, but important point is like at least in India, the instruments whatever available, they are not having the capability or the having the actual NO2 observation. They are having the NO2 plus some of the other nitrogen oxides. So one has to identify. So there are different specific technology that is still not we are able to utilize. And then for in case of NO, the observation or like for example for the radical, the observations are in the PPT level. So those are has to be made very carefully. Now, of course there are a lot of the experiment for the tracer, for biomass burning tracer, but this has to be done or miss it should be done in different part of India to identify the actual influence. And some another tracer is the dynamic tracer for the to identify the how much the transport from the upper height or how much moisture is going up. That kind of the study is also very important. That is, I feel it is important. And rest of the thing, of course, it is there. So I would like to conclude here, and maybe we'll be happy to take the question or something. Maybe that Anup can decide.
Yeah, thanks a lot, Manish. That was a wonderful overview talk about what has been going on in the world of trace gases and a little bit about aerosols also, especially considering we have so few observations of reactive trace gases over India. It shows how much data has been collected, but how much need for extra data there is. And I'm glad your group is playing a very important role in this. There are a bunch of questions. Maybe I'll try and organize them and ask them in sequence. So maybe one thing we can start off with is you mentioned over here there is a need for making observations of your radicals. And initially in the beginning of your talk also you mentioned how OH is the detergent of the atmosphere. So I guess the simplest question to ask is, do you have plans to measure this?
Very good question. No, so I don't have the specific plan for this, and but I will say this is my dream plan to suggest others. And of course, I will be but happy to collaborate, or if suppose somebody is keen, I will be happy to even provide the platform.
Excellent.
And
Okay,
but this
that's
is
good.
very much needed, and I know this Binayak Sinha is doing some this OS reactivity observation, but one has to have the direct observation, if not OH, but at least the HO2 or one can see RO2. So direct
Right.
observation. Yeah, here one important point which I missed, I forgot to mention the actinic flux like JNO2 or JR, like those are the looks like simple measurement, but somehow we are missing in India. It is very interesting. We don't have any observation of actinic flux.
That's interesting. I would have assumed that would be an observation that has been made. But yeah, so it's good you pointing this out. Vinayak's also on this meeting, so I'm sure he'll have a few choice of words regarding OH also. The next question I want to answer is in the beginning, you talked about how there is higher ozone at the high altitude stations as compared to the surface stations, which are at low altitudes. You did not really touch upon what are the reasons for it, because
Okay.
intuitively, because your
Yeah.
sources are closer to the surface, shouldn't you have higher concentrations at lower altitudes as compared to higher altitudes?
Yeah, of course, because of the I think I went slightly fast on that because of the I was having impression that I am slightly late on this aspect. Maybe I can just show this slide so then it is easy. Maybe I don't know the figure I missed it here. Okay, I can tell the verbally. The major thing like in the mountain side because of the high altitude. So when you go up, the background level itself is much higher. You don't have the daytime production, but the background level because the high altitude when you go like even you can see the when you have the vertical profiling. So when you go up slightly, the ozone level increases. So this is overall high level in the background. You can see the high level of ozone at the mountain side. But but again, one comparison one has to draw. Like mountain side is very clean, so you don't have the daytime photochemical buildup, so no photochemical enhancement. But same analogy if you put on the ocean side, so diurnal pattern in ozone is almost flat kind of thing over the ocean or the mountain. But because of the low altitude of surface, the background levels are very low in the oceanic region. Like if you remember, I was showing the diurnal pattern of the Indian Ocean, so that it looks like almost flat kind of thing. So one can say like here this slide, the diurnal pattern in Indian Ocean is almost flat. Why I'm saying flat? Because the 2 ppb difference or 4 ppb difference amplitude I'm neglecting. So same pattern you can see over the mountain side, but over the mountain side that levels are high. So because of the altitude.
Right. Yeah. I mean, traditionally, it's important to remember that the surface is a sink for ozone, which is why one would
Yeah,
expect
right,
lower
right. Yeah, that yeah,
concentrations
like
closer to the
daytime,
surface.
nighttime you have the loss
That's right.
because of
The
the
next question
yeah.
is regarding the NMVOCs, non-methane volatile organic compounds. You have mentioned about the big difference that you're seeing in terms of ethane and propane, especially at your station as compared to the foothills. And this also is a question somebody else has asked: is what about isoprene? And does it really matter what VOC it is? Don't they all eventually just lead to ozone production?
Yeah, that is very good question. And you can see that we don't have the isoprene observation. As one know, there is very high reactive. So one has to have very different setup. Of course, this again I will mention to Binayak Sinha. He is doing the isoprene observation. And because that needs very high sophisticated sampling technique, not only observation, but sampling is very complicated. So I'm not doing. Now coming the what was the other thing? I think
The other question was, I mean, it's okay to know about these different NMVOCs, but don't they all just produce ozone? So why does
yeah,
it
yeah.
matter which
Oh,
one
okay,
it
right,
is?
right. Yeah. So this is very basic on the hydro. So that's why the importance of non-methane hydrocarbon VOC comes. Like of course, this is the basically the on introduction kind of thing. Like for ozone production, the one can say the ozone production potential. We call ozone production potential. Like what is the basically one molecule of some gas like methane or C or hydrocarbon can produce how many molecule of ozone. So to start with, like for example, you talk in the hydrocarbon family, the methane, one molecule of methane can produce only one molecule of ozone, approximately. Similarly, like one molecule of CO can produce 1.5 or 2 molecule of the ozone. But if you come to VOCO, non-methane hydrocarbon, the one molecule of hydrocarbon, non-methane hydrocarbon of VOC can produce almost 15 to 20 molecule of ozone. So their ozone production potential is very high, and it depends on the which hydrocarbon we are talking. So that is largely vary. So like that way, again isoprene, the ozone production potential of isoprene is much higher than the other species. So it goes that way.
Right. It's important to remember that the number of carbons, they really matter in terms of how many ozone molecules it can produce. So larger molecules can actually produce a lot more ozone as compared to the smaller ones, as you say, rightly. Uh, Another question, well, one of the things you mentioned was about VOC dominated and NOx dominated production or limited
Yeah,
production, and
yeah,
how there is a very clear difference between seasons in India, especially in the north of the country. Very recently, there was a paper which came out by the British group talking about how in India we are also seeing an aerosol limited environment for ozone production. Can you elaborate a little bit about why that is and why is it so specific for India?
yeah. Of course, somehow I missed. I could not see that paper, but I would like to see it. But it is, of course, well known. And I remember when Paul Crutzen was alive, and he used to have discussion with Shyamlal. And I remember after the Indo-X and even after the Indo-X for until 5 to 10 years later, he was emphasizing on performing the experiment to see the act of the or how ozone and aerosol are behaving. And it is very much clear that when aerosol is there, like aerosol provides the surface, the ozone loss take place. Of course, this is known by theoretically. So it is highly possible. The of course, when we say the aerosol limited regime, that I may not agree, because the aerosol cannot lead to the ozone production. When we say NOx or VOC limited, that means there's some in some region they may lead to production also. But aerosol cannot lead to the ozone production. So terminology, of course, I'm yet to see the paper, but saying the terminology NOx aerosol limited regime for ozone is may not be correct, but definitely aerosol lead to the ozone loss. That is theoretically known, and some laboratory experiment has been conducted.
Right. So essentially, the implication would be that ozone concentrations over India would be much larger if we did not have the current aerosol loading.
Yes, 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 right, right. That yeah, that is true.
So
And
that
particularly, this might be more put more complexity in the northern part of India.
right, yeah, where you have larger aerosol loadings.
Yeah,
It's ironic how everything feedbacks into everything else. Aerosols are bad for health, but they are reducing ozone, which is also bad for health. One of the questions was regarding uh, well, I'll put two, three questions together over here. Should we be worried about pollutants being released into the atmosphere? I think the short answer for that is yes. The question, of course, is how can we control it? Now, one of the slides you showed that there is a large impact of emissions from much further away outside India on ozone concentrations within India. So emissions which are happening thousands, hundreds of kilometers away can actually increase ozone concentrations over India. So how much can we control ozone pollution over India by putting in policies in India itself? And is it a problem that needs to be answered through multinational policies rather than just city-based
yeah. I
policies?
think the question is very good, and that's why I was targeting basically to cover up the entire South Asia region, but somehow I could not do justification for that. But it is one has to have the basically policy which is governing the entire region. Like even if you have to deal with the Indian level or the pollution level in India, one has to even have the handshaking with the surrounding region or the surrounding country. And not only surrounding, like as I was showing, the can roll off from the slightly long distance, like even the northern part of Africa and southern Europe. Because the like for example, some of the species they are long-lived gases, like say for example carbon monoxide, so they can very well transport. But only thing, like also one should not, in my personal opinion, like one should not have the excuse that of course there is a major role or the contribution coming from the outside of the national boundary. So of course, the one has to focus on the emission control strategy over within own country. Of course, there's approximately one can say maybe some 10 to 20% contribution comes from the different part of the region. But
Right.
another thing, there was a very nice paper. I forgot the group, but a study was made over the USA. And what is argued, like whatever the emissions levels you are enhancing over a region, on top of that, the contribution is made from other country. So what they said, like if the contribution is absent from other country, you will be within your limit.
That's
So that
interesting.
is the basically one can argue that way. So if you suppose remove the contribution from other country, you are excessing very much within your limit. But probably I don't know how to justify it. But yeah,
And I
so
guess that's
one has
true for
to,
all
of course, I
countries.
agree. One has to have the collaborative effort with the surrounding neighbors to have this control strategy. That is very much true.
One of the questions that Sita CJ has asked is greenhouse gases from different sources like CAMS or ECM WF data. Can they be used for improving our understanding of trace gases over India?
Uh, oh, maybe I think I don't know what to say, but my personal feeling, of course, it might be okay to understand the process, but it is I didn't cover. We one of my student is working on that, and there is a lot of difference, and also there almost sometimes there level difference in the camps. That level difference are almost double. So there are a lot of uncertainty. So what I will suggest, it cannot or should not be used for the direct comparison of the level, but it is very good to, if you want to understand the process, like if you have the capability, if you have the full control, you switch off one process and then see what is the influence of that process on the region or the species. So for understanding it is okay, but not for one-to-one comparison or say, or making some claim on that. Yeah, this species enhance and something like that.
Manish, one of the things you've highlighted is the lack of enough observations over India to really understand the processes in detail. And this brings to one of the questions which Yash Dahima has also asked is, in terms of instrumentation, right now you've shown some instrumentations from ISRO, from yourselves, from IITM, etc., which have networks around India. But obviously the density of these networks is pretty bad. In addition to that, we have instruments from CPCB or the state pollution control boards. So the simplified question is, are the observations which are being made by these different players good enough to compare with each other? Are there instrumental biases? And what is the role that low cost sensors can play in terms of filling this gap?
I think for both the things, I may not have the very good taste. Like for CPCV, I don't know. Maybe this should be, I think, comments should be taken from the other people. But the because the one has to make the some comparison, and until comparison or calibration are not made, the it is very. I think people should use the data very carefully. I can say it that way, because we don't know the comparison, intercomparison, or the calibration. For the small sensor, I think for a small sensor, also very still those sensors are not very much mature. And like for, of course, for the PM 2.5, it is okay to use some of the sensor again with care. Like one has to have the very regular comparison, and also there is a significant dependence of the flow and the temperature surrounding sensor. So that also one has to have very careful the observation using those sensor. For gaseous thing, for a small sensor, they are still not mature, I say, because we are have seen the lot of the results. Those sensors are okay for using by the industrial group or for seeing the basically very high level of the species, like when you compare in the ppm level. But when you do on the research level, this kind of sensor may not be very useful for the, at least for the gaseous thing.
Okay, so that's a very good point. I think Professor Devra has his hand up. So Professor Devra, can you please unmute yourself and ask your question?
Yes. Yeah. Good evening, everybody, and particularly the talk by Dr. Manish is excellent, no doubt about it. But of course, he touched upon some of the research gaps in ozone chemistry. And then, in fact, after hearing your discussion about the relationship between aerosol and ozone, in fact, we also observed and then published the paper on heterogeneous chemistry. Aerosol will act as a catalyst, and then the surface area of the aerosol matters a lot about the
Yes.
ozone killing or ozone production. So what was contended that time by Paul Crutzen and all was very correct. There is a heterogeneous chemistry observed during that Indo period, and we are one of the witness for that. That is one thing. And then another thing is, I expected a lot of profiling you will talk in your talk. Vertical profiling, but of course I have not heard much about it. But anyway, you might have the sound knowledge about the profiling, particularly the trace gases. See, when we have made lot of observations about the using different platforms like one of the balloons and then aircraft and then so many platforms, but we have observed almost about 3 to 4 kilometers strong aerosol layer. So if you consider the relationship between aerosol and then this ozone, could you observe first of all any such layers in the trace gases also? That is number one. Number two, because lot of abundance of aerosol is observed during those structures, do they really impact positively or negatively on the structures of trace gases during at those altitudes? That is my number two question. These two regarding the profiling, you might have definitely observed in your studies, but of course they are missing here. Actually, that is one of my doubts to clarify. So, and of course, I will talk one more small thing: gas to particle conversion. Your talk includes the trace gases and then PM1, PM2.5, and this type of stuff also. So, could you comment anything about the salient feature what you have observed in the on the gas to particle conversion process, because that is also very important when you talk about the killing and then production of ozone is concerned. So these are all my small questions. I will be happy if you clarify or support.
Yeah, about the particle profiling, of course I agree that I could not touch upon more on the particle profiling. Particularly, we have the very extensive observation of the ozone from the balloon, and in fact, if I put that, maybe full 1 or 2 hours may be needed only for the ozone profiling. But just one relevant point which I wanted to show. So I showed, like during the biomass burning, we have seen very extensively that biomass burning not only enhance the surface ozone at the ground, but enhance the
I'm sorry, I think we've lost Manish for a bit. Hopefully his connection will connect again and we can hear him. Yeah, so let's give him a minute or so. Otherwise, we can move ahead. There are some other questions in the chat that have been answered. So Soumya, your question was regarding the ratios. And yes, Manish had already touched upon this. Yes, you can use these ratios for understanding whether it's going to be ozone production or not. And in addition to that, there are observations which are satellite based, but also ground based observations which are being made across India to understand this a little more in detail.
oh, I
Hi,
see.
Manish,
Yeah.
can you
Yeah,
hear us
there was
now?
some problem in the network, my network, or some, because I was seeing the
Your
5 minutes.
network.
Yeah, we lost you for a bit over there, but now we can hear you clearly.
Oh,
So,
okay.
yeah, you can continue with explaining about the profiles.
Yeah, so I was mentioning about this influence of the downward transport. So that we have seen, And coming to on the aerosol thing, of course, as expected, as I was mentioned also during the Cortison mentioned, like of course there is we expect and it's there like loss of ozone on the aerosol surface. But unfortunately, we actually for this kind of study, one has to have the profiling of both aerosol and the ozone together.
Exactly.
And of course, we have also seen the layer of the ozone, the aerosol layer around 3 to 4, and also another layer around 7 to 8 kilometers. And we have seen some loss of the ozone, but it is slightly difficult to conclude whether it is because of the aerosol only or it is because of some other chemical process, because then one has to have the profiling of the NO also, because the NO can also lead to the in very short time loss of the ozone. So it is very difficult to conclude. So this kind of thing can be possible only once you have the laboratory experiment or if you have the vertical profiling of other trace gases also. So profiling of the NO or NO2 or VOCs. So that will be, I think, slightly complicated to do the observation for the profiling purpose. That I will say.
Great, thank you. If there are any other questions, please feel free to ask. But before we wait for them, there are two questions that I'm asking each and every speaker as a part of this series. So Manish, and you've kind of answered it already. The first one is, what, according to you, are big gaps in the field of ozone that the next generation of scientists should focus on?
Yeah, so considering this question, so that's why, as you already mentioned, I have listed even my in outlook and the future need. And like I will say, there are two aspects. One, if you focus on the observation. So on observation also, I will split into two things. One, particularly when you talk in India, I'm still not very much satisfied, or I don't know why, the good quality of observation continuously for a long time. Even like you see the very simple species for simple for like for ozone, still we don't have the many observation site. Of course, there are some observation sites still people are doing like IITM or ISR Mohali and myself and other people. But you can count at
Oops, I think we've lost him again. So I'm assuming he'll join back in a bit. Let me see if there were any other questions that were kind of but not directly answered. Uh, Ankita, your question about anthropogenic halogen emissions affecting ozone concentrations, yes, they definitely do. Most of the halogen emissions are two types. One is obviously your long-lived species, which will affect stratospheric ozone and they lead to ozone depletion over there. And then you also have some shorter-lived species, which would affect tropospheric ozone chemistry. Depending on the species, it can either increase it or decrease it. So if it is bromine, iodine-based species, then they lead to ozone depletion. But if it is chlorine-based, they actually lead to an increase in ozone concentrations. So it really depends on the type of species and the lifetime. But if you're looking at tropospheric impacts, it's mostly natural halogens that have a larger impact as compared to anthropogenic halogens. But stratospheric ozone is definitely impacted largely by anthropogenic halogen emissions, mainly CFCs.
yeah, hello again. Sorry, I think the severe net. What I've done, I have switched off my video, so at least we can save some bandwidth.
Sure, sure. No, that's fine. You
Yeah,
can stop sharing your screen also if that helps
yeah,
you.
right, right. I will do that. Okay, so I missed the point what I was, yeah, okay. So continuous. So like for CO, NO2 observation. These are, I
Hmm.
say, very simple observations, but still long-term and systematic observations are still missing from the side. And
Hmm.
again, like coming back to old thing, observation of radical, actinic flux. These are the still, I would say, very simple observations, but those are making. Now, apart from the observations, one I see very, of course, I forget to mention in my slide, and that is again my another major wish list to have the observation from the satellite and in geosynchronous orbit. Like if we can call, like now the Korean group has already jumped and they have made first satellite like James. They are doing, of course, they are covering the part of the northern part of India. So they can have the, of course, the 6 to 8 hours of the observations of the trace gases and aerosol continuously for 6 to 8 hours over northern part of India. The recently, few days back, of course, I was thinking to include some the information on that. The USA has also launched the geosynchronous satellite for the trace gases. In India, we have the INSAT platform ready, and one of my students, for the first time, he has used that INSAT data for retrieving the vertical distribution of ozone. Of course, we get the total columnar ozone, but vertical distribution of ozone getting from INSAT is for the first time we have done it. But that platform can be used or should be used for the gaseous observation, for CO2, methane. These are the simple observation. So that is the another wish list, to have the trace gas observation from geosynchronous platform, and we already have the INSAT such thing. So that
Great. So I guess
from different IIT, they have the center for the ISRO center also. They can plan some small sensor satellites, a small like we call the low altitude satellite or scientific payload, and have maybe even if it is lasting for say 1 or 2 months, that is fine. But that is, I think, will give the good jump for the technology.
That's a very good point, and I guess that answers my second question, which was, what if we give you 100 crores, what you would do? So I assume you're going to go into space. But it's a very important point, saying that remote sensing has not been exploited well.
Sorry, Anup, I will interrupt in between, since you mentioned about the 100 crore, and I know that IITM is leading and MoES is doing that one dedicated aircraft. I don't know what is happening. I don't know. It is good to say this platform, but we have the very dedicated ship. But for the atmospheric community, there is dedicated aircraft is also very much needed. And it is, I'm hearing since last maybe 5 years or 10 years. I don't know what is the, but that I think should be done in high priority. And we should force the MoES to have that aircraft available for the atmospheric science community.
That's a very good point. And just to give you an update, unfortunately, there is an issue with the current funding situation, and hopefully in the future we will see it as the status of it. But yes, I mean, it doesn't hurt to wish for something that will really help push ahead the data gathering for atmospheric chemists in India, for sure. With that, I think we have answered most of the questions which have come up, and we've got a few comments. For example, Vinayaka said, "Thank you, Manish, for the excellent overview talk," which is what I will echo because we are all out of time already. So, Manish, thank you so much for giving a talk on this platform and mainly highlighting the need for more trace gas observations, which is often overlooked or definitely not researched as much as aerosols over India. And we hope that the effort that you, your group, and others are doing will really bring in more importance on trace gases in India in the future. Thank you so much.
Yeah, thank you. And again, one concluding thing I will say, like, I'm very sorry, like, because of some shortage or some mismanagement on my part because of travel, I wanted to cover different aspect also, but some of the aspects are missed. So I'm sorry for that, but let us hope next time.
No, not
In
at
fact,
all.
my wish, maybe after a few months, I can take one more talk and I can cover all those missing aspects.
Indeed, you're always welcome for this. And as you know, it was probably too ambitious to think that you would be able to cover everything that you've done in your career so far. So we'll definitely have you back here. Great. Thank you.
Okay.
Thank you, everyone, for attending.
Thank you, Dr. Manish. Thank you very much, Dr. Manish.
Yeah, thank you, Dr. Devra, for taking out time.
Thank you. Nice to hear.
Cheers. Thank you, everyone. We'll see you at the next talk, which will be announced hopefully soon. Thank you. Bye-bye.
Bye.